Good morning, good afternoon, good evening, and welcome to another episode of In the Clouds. Or I'm sorry, the Level Up Hour. I am totally out of whack this morning for a poor night's sleep. So confused, yes. This is In the Clouds with myself, Chris Short, executive producer of OpenShift TV, technical marketing manager here at Red Hat, as well as the illustrious Langdon White. Langdon, how are you this morning?
I'm pretty good. Doing well in the coffee. I think this is my second cup, so we're
good for you. I'm on my second cup as well. Awesome.
Yeah. We are excited to invite some also illustrious guests. Today. So we have. I'm gonna ask y'all to indicate the group you're with, because Red Hat has been renaming a bunch of the teams that we have quite a bit lately, and so I'm getting very confused. But first up, James Faulkner, you want to tell us a little bit about who you are and what you do?
Sure. Yeah. So thanks for having me on. So James Faulkner, I work in I'll make it easy for you. Formerly known as the middleware business unit, now the application services business unit. I do product marketing for our suite of cloud native runtimes for running a very horizontal set of use cases for applications. So the traditional ones: NodeJS, Spring Boot, Java EE, Jakarta EE, and now some of the more modern stuff with the things like Quarkus. So yeah, I've been at Red Hat for about almost 5 years. Actually, 5 years in February. It'll be 5 years. Prior to that, I spent a bunch of time in Sun Microsystems and Oracle, and I was also at LifeRay for a few years as well. So I've been in the Java space for, 12 years now, I think, something like that.
LifeRay, the portal that you got a Bible quote portlet by default.
Yes,
I actually worked on LifeRay for a little bit.
I've nice. I'm glad to hear it. I apologize if you had any trouble. It's all my fault. So
it was definitely one of the better ones. Yeah,
it was one of the better ones. My trouble was with our devs that just insisted upon having control of prod, and that was not good.
Yeah.
So yeah,
that's a challenge no matter which portal you're using.
Exactly.
Yeah.
Daniel, thank you for coming. Do you want to tell us a little bit about who you are and what you're doing at Red Hat?
Yeah, thanks, Langdon. Yeah, my name is Daniel Oh, and actually I'm working with James Faulkner in the same team, in the runtimes team. So yeah, I'm technical marketing major, a little bit more focused on technical stuff, like a creative workshop, demo, and a technical, some enablement for many developers in the IT operation team, really about the cloud native runtimes, Quarkus, Spring Boot, and Node.js, and of course, JBoss EAP, that is our still be cash cow. Yeah, so that's what I'm doing.
What I think is funny about Daniel and I is I think we live like 40 miles away from each other, but have never met in person.
Wow. Yeah.
Which is kind of entertaining. It's kind of like there's a woman who lives in Cambridge. So I live in downtown Boston, and Cambridge is like right next door. Mm-hmm. And I see her all the time around the world at conferences. I have seen her once in the Boston area, which I think is also amusing. So yeah, when you travel a bunch, it can lead to some entertainment.
Yeah. Sorry, Landon.
Yeah, go ahead.
One story on that. There's a guy that works at Red Hat that I've only seen at conferences, and we see him at almost every single conference. His name is George. He'll know. He works at Red Hat, and it's just hilarious every time we see each other. Like, hey, buddy, good to see you again. See you next week at the next conference, and we never ever meet up outside of that. So it's kind of fun.
Right. Yeah, it's
like you have your conference friends and your
friends. There is something to be said about the circuit. I often wonder if that's if it's similar for and much longer lasting in a sense for like actors and actresses, or like people who work in TV shows or movies or whatever. You only see them kind of on the circuit, or like comedians or whatever. Like I suspect it's a similar experience.
Yeah.
But obviously being me and a nerd, I only have experience with the software conference circuit. Nothing actually cool.
Nice.
So what was I going to say? Okay, so why don't we start? Oh, awesome! I just got signed out of Google.
Oh, good.
So that'll make things faster,
nice and easy, right?
Like literally, it popped up when I was about to switch.
perfect.
Yes. All right. Let's see if we can find the right window. But I'm going to share my my awesome slides that I do for every show. And I think I even corrected all of the bugs in them this time, which is even better. But what I like to do is to quickly start off, I like to say, in case you're lost, this is the Level Up Hour. On this show, we talk about why containers might be interesting for you, and maybe a little bit of an introduction to containers, and in particular, how containers are kind of like an easy, convenient way of doing things kind of all the time, rather than just this special technology or whatever that you use when you need to go to production or something, and so in particular we want to show use cases a lot of the time where non-developers might be interested in containers, but we also cover a lot of development stuff, and I think we're going to cover a little bit more on the developer side of the house today, but this is the Level Up Hour. Your hosts, Chris Short and myself. I'm Langdon with a 1 on Twitter, and Chris is Chris Short. And if you want to chat with us, you can chat in the whatever streaming platform chat you're on, and we will see it on Twitch and respond either on the show or on Twitch. But you can also join us in Discord, and we're there all the time. Maybe not all the time. Sometimes we sleep. But you can join us on our Discord. Well, yeah, occasionally. Yeah, it's a surprise like? To most people who know me.
What's that like?
Yeah, exactly. But you can definitely join us there, and we sometimes get into interesting discussions. We've been trying to flesh out the Discord to kind of cover all the shows as well. So any of the shows that we do on OpenShift TV, you can kind of come and chat with us there offline. Yeah, so. Do you have the, oh, you dropped it in already. So I was just looking for the link. Yeah. And I'm going to stop sharing here because, as we all know, the next part is the sweet internet points. And we don't want to give those away too early. Right. And Daniel and James, if you are unfamiliar, you will learn the awesomeness that is internet points very soon. So I asked the two of you here today because we have through the show, so oh wait, you know what? I did miss a slide. I thought I did. And here I was doing so well. And the reason I want to make sure I go back to it is because it's somewhat important to my point. So what I want to point out is this is episode 22 of our episode. So we've actually been doing this a while now, Mr. Short.
It's been quite a journey, though. I love it.
It has been. I think I taught you something new yesterday too, and it's been a while. So I was hoping to hit something today.
Yeah, you did.
So the show notes from last time are at the link below, and I will throw that in the chat.
I forgot to pull them up in advance.
I actually did this one. And the reason I want to point it out is because we have been doing the show for a whole bunch of episodes now, and we have been recently covering or been using Nextcloud as kind of our example application. And Nextcloud is cool and does its stuff well, and that's a little bit the problem. In that you
we can't break it enough.
Right, we can't show like I want to do this brand new thing off to the side and change things around and and use canary deployments and that kind of stuff because Nextcloud just kind of does its thing well. So what I was asking around about and came across James. I think that you answered me. I can't remember how I got there, but you have a tool or an application that you've built that is for demo, so you get to break it, but is also more complicated than Hello World. Right. And so what I wanted to invite you on the show about was to talk about that application, but then the part that I think you also did, which I'd also like to talk about, was I think it was actually a migration originally from a monolith application.
Yeah, that's right.
Correct? Okay, so that's an even better story. So why don't you tell us a little bit about the app and what it does, or maybe a pointer to where it lives and that kind of stuff?
Sure. So the CoolStore is it's a retail shopping. It's a fake retail shopping experience. I did not write the original one. The original was written by Eric Chabel and a few others, really intending to showcase not necessarily the retail experience, but showcase our business rules management system, how business analysts can, edit a spreadsheet so that they can alter the shipping or promotion costs or promotional details without having to go in and code. So it kind of separates, the business guy from the coder. And so that was originally a monolith, a Java EE, essentially a WAR file that gets deployed, had the BRMS or Business Rules Management System technology in it. It also had a front end written in a web toolkit called Vaadin. And it had a few products. You select the products, you click the purchase button, it calculates the shipping costs and any promotional details based on the BRMS rules, and then you get your result. And when I joined Red Hat in 2016, microservices were all the rage, and also all the rage was container orchestration with OpenShift, and the OpenShift 2 to 3 kind of transition that was in that time period. So we really, I thought it would be a great example because you're right, everybody knows retail, everybody uses some kind of online shopping. So it's a very familiar use case. And so it's easy to add features and demonstrate various technologies using those features. So adding things like an inventory system or adding a payment gateway or something like that. And all fake, of course, but we really used it as a way to showcase containers and OpenShift, as well as the microservices capabilities that people like Burstdata were talking about very heavily at the time. So it was a monolith, and we basically converted it into a set of microservices, and then built some demos and workshops around that to showcase and use some of the tooling to do that migration from a monolith to a microservice, and then along the way adding features from OpenShift like blue-green deployments and build pipelines and things like that. So that's sort of the genesis of that application. And so in more modern times, we've continued to add new features like we've added an API gateway, a poor man's API gateway, if you will, with Camel. We added a single sign-on. We added InfiniSpan for in-memory data grids for storing the shopping cart details for each user, things like that. We also rewrote the UI because although Vaadin is great, it wasn't what people were looking at when they're looking at microservices. A lot of people do things like single page apps and front ends and things like Angular and React. So we wrote the front end in Angular, turned that into a microservice as well with Node.js. And so we had all these different technologies kind of sitting in this one demo. And so a lot of the field folks at Red Hat started to take that and use it for demos and workshops and whatnot. So
yeah. So I mean, what's cool about that, we've actually within our group, we've been talking about actually moving all of our demos over to the same platform. So basically we can kind of have like the one demo that rules them all. Mm-hmm. In particular, what I also enjoy is and the kind of thing I like to show off is in a real world application, the likelihood it is just one programming language is very low. So what I particularly like is that you kind of have kind of a Node.js component as well as a bunch of Java components. Even going back, as horrific as it is to say, using Java front ends against a mainframe, right, is another common scenario. Totally. Even today, which is scary. And one of the things that Narendev brought up in the chat, actually, which I'd point out too, is it also allows for kind of, and this is one of the things that's true about kind of a service-oriented model in general, whether you call them microservices or macroservices or services or small chickens or whatever you want, it allows for change over time around the feature set that you want to offer, right? So he brought up AI, for example, and AI for analysis. So that's a very good example, is like, how well are your, widgets selling when you're, if you have the price point at X versus if you have the price point at Y. And we talked a little bit about this last episode. We were talking about service mesh and kind of red black, or I keep doing this. It is red black. Red black deployment of applications, so that you can kind of say, okay, I'm going to try this UI and see how it performs, or try this price point and see how it performs, and try this price point presented in the same application, but to different sets of users, so you can get some feedback.
Yeah, some people call it A/B testing as well.
Yeah,
marketing
A/B testing.
Speak. Yeah.
A/B testing, I find, though, in the industry language tends to be really limited only to UX tests.
Yeah, I agree.
Actually, I meant to bring this up at the last episode, is someone's presidential campaign. I want to say it was Hillary Clinton, but it could have been somebody else. There was a story about how they did an A/B test with 2 different size donate buttons, and it made like an astronomical difference, like orders of magnitude difference in the amount of donations. And now, of course, I can't remember whether the button was bigger or whether it was like where it was placed or whatever, but they actually did an A/B test with their donate button, kind of layout, and it made a huge difference.
Yeah, it's kind of interesting how the user experience and UI can really affect your decisions. Like even in the CoolStore, one of the things that I found really early on when I first joined Red Hat, and I looked at some of the existing demos, they were like the big money shot was like the log file scrolling by, and you're like, look, it works. I see the value changed from 1 to 3. Isn't that fantastic, Mr. Customer? It's like not all that impressive. So I know there's some massive super computing going on underneath, but seeing that line change is not that exciting. So
I would say, as a developer, log files are the bomb, right? Yeah. I mean, you want to, seeing your own log file scroll by without errors is like an amazing experience. But I get the impression that nobody else cares.
Yeah.
For example, I don't want to see Amazon's log file. I want to see a transaction occur and then something show up at my house. But yeah, I totally get you. What I'm really curious about, though, and kind of I think relevant to kind of the audience in the show, is like, so what was the experience, or how did you go about taking kind of the monolith to the microservice side? What complexities were there? What were the things that you didn't expect to be a pain in the butt that turned out to be, or that kind of what are the gotchas?
So yeah, that's a good question. One of the things that I used when I started this process was, I mentioned Bursutter. He had this presentation where he kind of showed a very crude, if you will, depiction, like an illustration of a retail site, showing the different microservices and how you can do API chaining, where one calls, A calls B, calls C, calls D. If D fails, then it can cascade back, all the way back to the end user, and they get that stack trace or an error message. And so one of the things that one of the other options is to do either client-side or server-side API gateway. I mentioned an API gateway where you have a single entry point, and then that gateway makes decisions and calls different microservices and pieces things back together. That turned out to be kind of hard to code myself because of all of the different HTTP verb rules, and I also was learning Camel at the time, and trying to sort all that out and set up the different rules for the different routes essentially for the different microservices, and then aggregating those pieces back together turned out to be relatively challenging. Even though we kind of made the microservices return kind of simple JSON objects, aggregating that together and deduping and returning a sane result turned out to be not that easy. There's lots of gotchas with HTTP, especially if you're doing HTTPS, which we were also doing with having like CORS headers and trying to get the certificates deployed correctly and things like that in the JVM that was running the API gateway. So that turned out to be challenging, but at the end of the day, it was, I think, the right way to do it, because you kind of want, in a microservices and containerized world, you kind of want to hide the implementation detail of your backends, so that if you want to make a change, you don't have to go update the client. Because if your client is a mobile app on the App Store, for example, the Apple App Store, it is a massive pain in the butt to update an app quickly. It's like you got to do all kinds of crazy stuff to be there. So hiding that stuff was kind of a pain, but also worth it at the same time.
Yeah, I mean, have a conversation with someone at Red Hat who works in RHEL and talk about updating, say, RHEL 4. It ain't just mobile apps. So one of the things I wanted to comment on was, can you expand a little bit on what Camel is? Because I'm not sure our audience has a lot of familiarity with it. And you keep talking about it, and I think it's personally very cool. So I think it's an important thing to talk about a little bit.
Sure. Yeah. So first of all, I'm not a Camel expert. I didn't know about Camel until I joined Red Hat, so I probably won't do it the justice that it deserves. But it is an integration technology. So if you want to glue one thing to another thing and not have to write all the logic yourself, they have a ready-made set of connectors, and they also implement a number of patterns that have emerged throughout the years of doing distributed programming or distributed computing, where you can have, like, if you need to make a call to 3 microservices or 3 other services and aggregate the result, it can do that. It can do filtering, it can do chaining, it can do all kinds of interesting architectural patterns. And then it also has the connector. So if you want to hook up your super modern, like, React front end to a FTP server or some other kind of server that you maybe not familiar with, there's probably a connector for it in Camel. I think they have 300 or more.
Yeah.
So it's really an integration technology, and it seemed to make a lot of sense as an API gateway, because that's exactly what I was doing. I was calling different services and then filtering and aggregating the results. So that's what Camel does. It kind of glues things together.
So is Camel different than Camel K, or is that the same thing?
It is. They're related. Camel K is essentially a way to run. So when you're building an application with Camel, you create what's known as a Camel Route, and it's basically a snippet of code that says, if this call comes in on this address or this endpoint, do this other thing, and then return the result. So that can be expressed as a Java application using Camel. It can run in an app server. It can run as a runnable jar file or whatever. Camel K takes it kind of the next step further, where instead of you building a container and deploying a container, starting up a pod, and there you have it, you simply take your snippet of code and you submit it to the Camel K runtime, and it then chooses a runtime to actually execute that, kind of like in a serverless or function as a service model.
Cool.
So you can basically use the same Camel that you know and love in sort of that serverless context. So that's actually one of the things we're looking to do in the CoolStore, amongst many other ideas that we have no time for. To Langdon, you might be interested in that, adding stuff like that. We're looking, you mentioned AI. There is, you could imagine a feature where it's like, if you bought this thing, you might be interested in these other, or maybe that's a machine learning. I don't know, I'm not a strong differentiator. I don't understand the difference that much between AI and
we
ML.
covered that in the show.
Yeah, good.
This is a personal pet peeve of mine. So modern thinking right now is that machine learning is a subset of AI. Basically is that it's a subcategory.
Yeah.
But if you go back to my AI work in college, you would disagree. But we covered that in the show, and it entertained me at least, and we will definitely cover it more in the future, is my goal.
Nice.
So Narendev, one of our regulars, asked, is Camel K mainly Java oriented?
That's a good question. It's obviously does do Java. You can also write routes with XML, and they also have a DSL that you can use. I believe is also Java. I think they do have other bindings. I'm not entirely sure on that.
Yeah. So I was going to answer that as being kind of a wider. Like, I've done a lot of stuff besides Java as well as Java. It's a very Java world thing, but it is definitely used elsewhere as well. And this kind of goes back to that service-oriented kind of model, right? Is that Camel is like it's more like a service platform than it is like a language binding per se. If you think of like what do you call it? communication, like a message bus, right? It's like many message buses are Java world, but or even written in C, for example,
Right.
for performance. But their experience to a Java user is very Java-esque. So you have, so it's similar to that in that, you know, in the Java world, you see Camel a lot. In the Java world, you also see message buses a lot, but that doesn't mean they're not in other worlds. I would say it's more application domain. So if you're doing true, you know, kind of in-house IT or even public facing, but like true business software, you know, or B2B type software, that kind of stuff, you'll see Camel a lot, as well as like message buses. You know, I did a lot of work with message buses, for example, because I did a lot of stock trading or stock company work, you know, which was a lot of stock trading. And Camel is also a big integration layer as well. And one of the things I was going to bring up is to your earlier point about kind of the business logic stuff is that's actually one of the reasons like the mainframe stuff is often still there, is not just because the mainframe functions can perform so well, which they really, really do, right? They just, you know, they're so much faster than almost anything else, but also because no one is quite sure what the business logic is anymore.
Right.
And so as a result, it's actually safer and better to front end the existing transaction, sometimes even through regulation, right? You might have to go and get reapproved if you're an insurance company or something like that. And if you can't replicate the results exactly, you won't get reapproved without a full-on audit and that kind of process. So, you know, so you use things like these integration frameworks of various sorts, message busing, Camel, you know, even like it wasn't JBoss, but IBM's app server, which I'm blanking on the name of.
WebSphere.
WebSphere, yeah.
WebSphere was always really well known for its integration with mainframes.
Yeah.
Shocking, right? But you know, so you use those integration layers basically so that you could hide that complexity, and it would still be there, but at least you could worry about it another day.
Yeah, I think ESBs also grew up in that time.
Oh yeah, yeah, right,
Yeah.
right, of course.
So Camel is not like Nats in the sense it's just a message queue. I mean, and Nats is obviously a lot more than a message queue now with their 2.0 release, but think of it as kind of like a glue layer between all the things that you want to like tie together that might be disparate, different, like the service is written in this language, the service is written in this language, and we need a way to talk to each other, and this is it, right? Like, is that a good description, James?
Yeah, exactly. It kind of enables distributed integration, where like in the past you had sort of the integration competency center, and when you needed a new integration, you would go to this team and they would take 6 weeks to build it, and it might not be exactly right. Now you can kind of essentially do client side, right? With Camel, you can kind of build in that integration into the individual pieces and kind of distribute the load of building integrations from a single centralized team out to a distributed team. So which also lines up well with microservices.
Well, and almost as importantly, if not more importantly, your vendor can deliver them, right? So your Camel vendor, you know, Red Hat, for example, can say, here is a Slack integration, for example, you know, or whatever, and give you those pipes, you know, or like Camel and maybe I'm mixing my groups, but Camel and Kafka, for example, are big, like coupling these days. And, you know, kind of like with OpenShift, for example, you actually have a bunch of this stuff just integrated. So you just can kind of consume it rather than having to build the bridge as well.
Right.
Which is, you know, because it's a standardized way of doing these things, all that stuff, then you only have to build that, you know, Slack. The reason I'm thinking of Slack is just because I was in a like future of OpenShift kind of meeting the other day, and Slack was one of the things that is in the pipe. So, and as Chris often says, we live in the future on this show, and some of the future may or may not happen. So, you know, take it with a grain of salt. But I did hear that Slack integration was one of the things they want to see coming through to OpenShift.
Yeah.
And yeah, so. I don't know. I think I like these integration tools are like hugely useful, you know, even in your personal life. If you just think of something like if this then that, that's the same concept. You know, they aren't using, or maybe they are underneath, we don't know. But you know, they're not presenting it as kind of this same standardized model, but it's the same concept. It's like, I have a message, you know, I have a message or a packet of this format over here, be it Slack or Twitter or, you know, whatever, and I need it to cause some event over there. And so there's some sort of manipulation or translation or whatever that kind of happens along the way. And the more we can standardize that, the less often we have to build it.
Yeah, and there's actually some work going on in the Knative space around this. So Knative, we have Knative, the serverless framework, which is really good at scaling, you know, pods up from 0 or down to 0. Then on top of that, we have events and then functions. And so this whole notion of kind of like if this and that, like throwing off events from a producer and then responding to those with a consumer serverless function, we're starting to see that as well as also a way to integrate things. So more and more vendors are producing these cloud events, and there's a standard being developed in this Knative projects for representing those events for an event-driven architecture, and that's one of the things that we've started to incorporate into the CoolStore as well.
Actually, so, you know, I don't really mean this to be turning into a camel show, but somebody asked in the chat about Camel versus Red Hat Fuse, and I think that's an important thing to answer, and I don't know if I can do it justice. So,
you gonna try?
No,
you want me to try? Okay. Yeah. So I mean, it's the short answer is Fuse is the Red Hat productized and supported version of Camel.
That's what I thought. Okay.
Yeah,
okay. Right.
Yeah,
I wasn't completely crazy.
Yep. That's kind of Red Hat's. That's our bag, baby. That's what we do. Productize and support open source. So,
yeah, I remember that. Yeah, I did a bit of that with this other product we have. It's called Linux.
Yeah.
Yeah. So I did that for a while. But all right. So I don't know. Were you able to prepare some demos? Do you want to show us the app or?
Yeah, I can show you. I can show you some of the app.
Something that's going to light on fire, because that's always better.
Let me. I'll go ahead and share my screen and see what I got for you here. Let's see. Okay, so let me switch to my desktop here. So I had just a couple. I have a screenshot, and then I have the actual running app on OpenShift that Daniel also helped. And Daniel, feel free to chime in if you want on running on OpenShift. So this is the original CoolStore. This is the genesis of what we consider to be the modern CoolStore demo from Red Hat today. You can see it's a retail app. You can choose some products on the left. You click Add to Cart. Then you click and you see your shopping cart totals get summed up over there. The promotion and shipping gets calculated through that business rules thing I was talking about, and then you can check out. And so that's sort of that was the basic demo. It's a monolithic demo. You build a WAR file, a web archive file, which has the VRMS guts in it, and then you deploy it to an app server like JBoss EAP. Or WildFly, and so that was the original monolith. So that's just a screenshot. It is still available. You can still run it on the. I can throw a link. I'm not sure where I would throw a link if I wanted to.
Throw a link in the Zoom chat. I'll pass it over.
Okay. Yeah. So I'll throw a link to that in a second. But this is the original CoolStore, and then so we took that, and one of the ideas was, as you mentioned earlier, Langdon, the mono to micro, the migration. This is Red Hat has tons of customers. I'm sure there's many others out there that have existing apps that they have no idea what to do with them, but they just know they're old and slow, and they want to make them fast and awesome and compete in their whatever industry they're in. So digital transformation is the name of the game, and that what that boils down to in reality is taking applications and either kind of lifting and shifting them over to a different platform that has some features like OpenShift, or refactoring or rewriting, going from a monolith to a microservice. So we have some tooling at Red Hat that we took that tooling, we took the monolith, we took the rewritten microservices and turned that into a workshop. And so the end result is, and this is all running on OpenShift. And so we use a lot of the features for container orchestration that you find on OpenShift for doing advanced deployments, for doing CI/CD pipelines, and other aspects of the platform in more modern times, things like OpenShift serverless and service mesh with Istio. So this is let me switch to the other one first. So this is the monolith lifted and shifted over to OpenShift and onto JBoss EAP. part of this is a competitive thing where we show an existing app written in Oracle WebLogic, and then we use the tooling to migrate it over to a much faster and lighter weight product. Sorry, this shouldn't sound like a sales pitch, but that's the point of the workshop. So
we like faster and lighter weight on this channel. Don't worry.
Yeah,
and I was a big fan of BEA WebLogic.
Yeah, okay.
Before it was Oracle.
Yep.
You don't do just out of curiosity, is this source code for the lift and shifted version available somewhere?
Yes, it is. It's part of the source code for the workshop and demo, so it is available. Okay. We can throw some links in there too, Daniel, if you want. If you're able to throw a link into for the monolith source code, that might be useful to see.
Yeah, just to throw it out there for anybody, kind of for the audience, right? Is like, I have a talk about, or I have a lab I do at Summit about this. Is that like, do not try to magically convert your monolithic application into services. Instead, do something like a lift and shift, get that whole janky mess into containers just any which way you can, then start pulling out pieces and making nice services out of it.
Yeah, strangler pattern is what it's called in the DevOps world. Yeah,
strangler pattern it's good in theory, but there's and Langdon, we talked about this earlier. Like, from Nextcloud is from what I understand an actual production app. This should ever be used in production, and because we take a lot of shortcuts when we're doing this, right? And so like. For example, when we move to Microservice, so this is the monolith running here. I have a single Postgres database backing this thing. I'll just go ahead and click on it, and it's the store, right? Now it's a modern version of the store with new images and a front end that's a little more dynamic. So you can add to your cart, and you can check out your shopping cart, and you can check out and buy things, and it's all good. Notice I never logged in, so there's no single sign-on. There's single sign-on support, but we haven't added it in this particular demo. But we also took a lot of shortcuts as far as migrating a monolith to a microservices, because you have, in this case, a single database. In the other case, we're going to have like 8 databases. The challenge of migrations is not necessarily in the code; it's in the data, because that's where the value is for companies, and that's what they really care about. And if you blow that up, you're in deep trouble. So, taking a monolithic database and converting it to a microservice, now, number one, you no longer can do joins, right? Like database joins, like SQL joins, and number two, you can have potential for corruption if you don't time things correctly. You could have 2 microservices trying to change their state, and then they get out of whack, and then there's no way to reconcile that, because you don't have the protections that you would have in a monolithic database. So we sort of hand wave over all of that in the workshop and say, a true mono to micro, you're going to be hiring, or doing either in-house or some expensive consultants to come in and do things like event storming and domain-driven design, and exactly, and do it right, instead of just what we do in the workshop, which is we go from monolith to microservice like magically. So
I will say though, if you want a good example of where it is done with a production application, even if that application is not terribly complex, although I think data storage is always a challenge, the Nextcloud actually does have both. So they have a monolithic version, and they have a service-based or service-ish based version. And seeing all the changes between those two, because they ship both these days, is really, really interesting. So yeah, I would definitely recommend that for anybody who wants to kind of learn how to do it as a kind of another example. But I think the nice thing about a demo version is that you do skip over some of the complexities, because the complexities are like kind of unique to the application that you're working with usually, anyway. So if you can kind of get the broad strokes, from something like a demo application, I think it is a good start on how you might need to do it, or how you might deal with your own application.
Yeah, and I will say the original monolith, even though it was a monolith, it wasn't just a flat set of code. I mean, it was still kind of structured service.
Wasn't that ugly?
Yeah, it wasn't that ugly. I mean, it had like, Java packages with, model and service and impls and, kind of the standard way to do a monolithic app with multiple different functionality. So there was some level of kind of one-to-one mapping. If you look at the source code of the original monolith versus the source code to some of the services in the microservices one, they're not drastically different because the logic is more or less the same. So it wasn't that much of a lift. And so the tooling that we have to do this sort of, I won't say automated, but assisted migrations kind of looks at the source code. This is a migration toolkit for applications. It's an open source product from Red Hat. It looks at the source code and it kind of makes recommendations. The easy stuff is like, yeah, you're using this proprietary API from Oracle. You really probably should be using the standard one from the Java EE world. Those are easy, but the harder ones are like doing, refactoring of large chunks of code. And so we kind of walk the user through doing that in the workshop. So yeah, but we do take shortcuts and we call them out. We're not trying to say that it's magic, but yeah, it's definitely something that you have to take into account when you're doing an actual migration of a production app. So this is the monolith. And then in the workshop, we kind of walk through creating the different services. So we have an inventory service. You can see there's a little number here. It says like 500 and something left or 734 left. There's a little icon for a location. And then there's the products themselves, like the descriptions and the images. And then we have
and you promise that if I add to the Kubernetes shirt to the cart and then buy it, it'll show up in my house.
Oh yeah, absolutely.
Yeah.
Awesome.
Yeah, we totally do the whole payment gate, PCI compliance and demo and everything. Yeah, no. Yeah. So that's the monolith, and then over time we take them through the microservices journey, and we not only do the transformation of the business logic, but we introduce some of the concepts in the illities of a microservice, like reliability and fault tolerance and scalability and so forth. And then we end up with, I'll switch over to the other namespace in this OpenShift cluster called user1-cloud native apps. And this is the sort of the end all be all microservice version. There's lots of stuff going on here, but you can see the individual services. Like we have a cart service, which is backed by an InfiniSpan data or JBoss Red Hat data grid, which is an in-memory data grid. There's the order service, which handles ordering, and it's backed by a Mongo database. There's the payment gateway, which is using serverless technologies with Kafka to respond to orders that when an order is placed, something is pushed into the Kafka stream, and then that's responded to by this serverless component here, the payment service. And then we have our Kafka cluster. And we have an inventory service, which and a lot of these have little mini UIs on them, which we use throughout the workshop to kind of give, it's hard to get your head around all this at one time. So we kind of build up slowly. So we say, okay, build the inventory service and go make sure the fake inventory UI is okay. And you're seeing the locations and you're seeing the quantity and the item ID. And then we also do things like we'll kill off the pod and this thing will go dead and then come back to life automatically through self-healing of pods, which we kind of demonstrate some of the health probes in Kubernetes. So that's kind of a simple example. We have some others. We also have a Spring Boot catalog service, which shows you the different things available in the catalog. If I can click properly, I'll show you the catalog, which is kind of like basically the UI, but boiled down to a table. Name, description, price, inventory, or quantity. So yeah, so we use these services, and this is it. This is the kind of the end state of the end of the workshop after you get through all this. This is like a full day workshop to kind of build all this up.
And you kind of put all the pieces, they kind of start to show up as you kind of go through the workshop, essentially.
Yeah, exactly.
Yeah,
exactly.
That's cool. Yeah. And that's what you linked to earlier, right, Daniel? That's what you linked to earlier. Is that workshop like the path for that, or?
That was the monolith one, right?
Yeah, there's a monolith. I'm gonna put in that this cloud native repository as well.
Oh, okay, cool.
So here's the front end. So the big finale here is you go in your cart, you add something to your cart, you head over to your cart, you check out, and then we ask you for payment information. So don't copy this down or buy anything. Right, expiration, CV. I'm just making stuff up here. 1940, nice. just put in junk, you check out, and then when you check out, that kind of fires everything off. And you'll soon see this payment starts to come alive because the order was posted to Kafka. The Kafka, our serverless payment gateway responded to that, noticed that, got an event from Kafka, and it came alive and processed that payment. And then with some built-in delays to simulate sort of real life delays. And so then if I head over to my orders, you can see my order here is now been completed. I think I can't see because of the Zoom window. I
it's very,
get that
it's very
small.
Yeah,
that is really tiny.
Oh, sorry about that. Yeah, so we kind of use this.
There we go. That's the size we like.
Yeah, so I can make all this stuff bigger. Just I should have known of that. I should have known. Anyway.
So actually, just because we keep mentioning it or whatever, and I have this weird history, but can you explain a little bit about Kafka is? Because what's funny, at least for me, is that when Kafka came out, it was essentially real-time Hadoop. And almost nobody talks about its ability to do that anymore, which was, basically a map reduce functionality. But that's what it kind of originally launched as. So in your mind, two people who kind of use Kafka all the time versus somebody who kind of just watches the trade press about it, what is it for, or what does it do?
So, hey, Daniel, do you want to take that one?
Yeah, so sure. So Kafka is based on address your distributed messaging. So you can actually use the just a simple message broker to handle your topic message or payload from your application or some client-specific site. But sometimes you got a lot of tons of the payload or messaging from thousands of your Microsoft application. So Kafka cluster definitely can handle their distributed metrics and distributed payload on your cluster, like a Kubernetes, but a lot of thousands of Microsoft application. So we're going to showcase the Kafka cluster in this microservice architecture, how to use that. And then even though this is simple retail application, we don't need to handle the tons of the traffic, but we can showcase how to use that thing with the Kafka cluster, with the serverless technology, with some mingle both of technology at the same time.
Well, and we know it's like super scalable, right? Because it came out of Twitter, right, originally, and it's how they used to do the what's referred to as the Twitter fire hose, which is actually a very hard license to get, where you can kind of get all of Twitter's feed, which I think it's limited to like 6 companies in the world or something. One of them, oddly enough, I don't know if they're still around, but there's a Boston company called Crimson Hexagon, which tells you about basically they do social media monitoring for your company or whatever. And so they had a Twitter fire hose, but it's like, could we have a more like Dr. Evil sort of company name? Because I was just like, really, Crimson Hexagon, huh?
Yeah, no kidding.
It's a little weird. I mean, it's a little bit more explainable because I think it's a Harvard like incubated company, and and Crimson is Harvard's colors. So you see crimson in the Boston area a lot more often, I think, than you see it kind of elsewhere in the world, just because of Harvard. But yeah, so I used to have some friends who worked over there, and I was just like, that is the best company name if you are super evil. But
which it is social media, so who knows, right? Like
yeah. Yeah.
Anyways.
So all right, cool. Thank you for that kind of little kind of sojourn around Kafka. And yeah, so this is kind of what I wanted to show, is that here we have kind of a put together fully kind of microserviceized app, right, that we can do experiments with, right? So we can actually talk about how can we, hey, we want to do our payment gateway, we want to switch from payment gateway A to B. I actually used to know the list of 4, but I can't think of them right now. But maybe it's just like Stripe to, to somebody else. And you can do that with something like a canary migration, for example. And you can have kind of in parallel accounts with them while you're running, and then and just basically farm your traffic across. So what else? Actually, somebody in the chat,
there's a bunch of questions in chat I wanted to
kind
of follow up on.
Why don't you tell us what they were? Because
So I'll just go in order here. So Islam I'll screw up your last name, Eldemiri.
Eldemiri?
Yeah. Are these solutions available? Yes, that's in the links. But he also asked, what are the most challenging obstacles when promoting the solution objects across environments / pipelines?
Oh, that's a good question. I mean, it's a generic challenge. I mean, with or without OpenShift, it's challenging to do that, like safely in a production environment, to replace one service with another or move it from, you know, a developer's desktop to a test environment to production. Obviously, Kubernetes and OpenShift make that easier with things like namespaces and you know, the container image storage and the way that sort of containers are quote unquote promoted across different environments, which I assume that's what the question was about, like going from a developer, you know, dev to test to production. And if you can then incorporate pipelines into that, it makes it even easier for the developer, just because all they have to do is push code. So I guess the challenge in that case is just kind of setting it up, but it's not that difficult. I think the hardest thing is for the workshop is creating all of the sort of YAMLs that we need to deploy these things. And I know that that's getting easier over time. I know as our developer tools get easier to use and more powerful, that will be reduced over time, but it's still, you got to kind of have some YAML descriptions of these things to get them deployed very quickly, to do things like setting up a workshop so that they can then, so the developer doesn't have to do that. So all the pain we experience in setting up this workshop is something that you would have to experience in a production environment, in terms of getting an application defined and deployed and flexible enough to be able to migrate pieces across different environments. And then on top of that, there's the challenge of what we talked about earlier, like A/B testing or blue-green deployments or dark launches or whatever you want to call it, to where you can kind of you know, distribute traffic across different implementations based on safety. So if you want to, you know, bring in a new version of the payment gateway, maybe you want to only expose it to 10% of your users and see if the thing blows up, instead of exposing it to all 100% and it blows up and you're out of business. Yeah. So those kinds of features, I mean, they're great features, but you know, still there's some challenges in setting that up.
So the next question is,
I was just going to ask,
go ahead.
Comment on developer tools. One of the things that you see over time is developer tools get better as the people developing developer tools start to understand the problem better.
Yeah.
And kind of by way of example, one of the things that I read that was really, really interesting about why IDEs are useful versus text editors is basically, if you have a highly dynamic changing language, like a language that is kind of changing how its constructs happen in a sense all the time, people who can use that language tend to be text editor people, because an IDE won't help you much. But if you're using a language that is not changing as much, for example, you know, Java or or even or C# or whatever, the languages are a little kind of slower to drift, and so the tooling that you get inside an IDE is actually much more useful than it would be in, say, a language like Python. And so I thought that was a really interesting kind of comment. So basically, it's like, as a language matures, you get IDEs, you know. And so as I think we see these microservice oriented applications mature or exist for a long time, essentially, I think you're going to see more and more tools, and you've seen this already, right? That make the migration to them or the creation of them faster and simpler and easier, and reducing the complexity. Because basically we have to understand the problem before we can write fixes for them. And I think that's been really an interesting journey.
Yeah, there's so you're absolutely right about the language stability leading to, you know, more feature-rich IDEs, but that also can apply to the intersection between the developer's IDE and like the deployment target. So if, you know, once you're done writing the code, then what? Like normal in a very efficient production environment, you would push code to Git or GitHub or wherever, and then that would set off some pipeline that would go off and do it. But for a developer who wants to kind of do that ahead of time, they want to be able to deploy on their own desktop, right? The tooling for getting an app its dependencies defined and deployed, and then running the app in a sort of a production-like environment. I think that tooling is still in its infant stages, and I think it's getting better with some of the work in the Eclipse project, Eclipse J, and which is a web-based IDE, but they're also working on defining how a production-like environment can be instantiated by a developer, so they can run this code after they're done writing it in what would look like a production environment. So you have a fake database. I mean, it's a real database with fake data, but it's using the same schemas as production. You have the same services as production, and you can kind of test your code. So that's a really important advancement that I'm seeing personally. The other one I found really interesting is Istio. We didn't talk about service mesh much today. We do use service mesh in this application, but it was an interesting article someone posted on one of the internal Istio boards about the title of the blog post was Istio. Essentially, the paraphrasing it is like Istio should fade into not obscurity, but fade into the background. It should not be something developers have to care about today. And so I think that as technology sediment into the underlying platform, I think they should, be essentially transparent when they're intended to be transparent, and not have to have a developer write some crazy YAML or understand even what a service mesh is. It just kind of becomes part of the operating system of the container platform, if you will. So yeah.
So next question.
Sorry.
No worries. Let's talk about just Kafka for a second, because it is very, very powerful. And the question is from Michelle Orlandi. MQ is a subset of Kafka, right? And yeah, like there's a lot to Kafka, so I will let y'all explain that piece.
I don't think MQ is like a message queue in general, like the durable messaging concept. I think they share some things in common, right? Kafka has topics and subscribers and pub sub and that kind of stuff. It doesn't aim to solve the same set of problems that a message queue would solve. Kafka is very good at storing large amounts of data very quickly in sort of a time series. You can then go back and replay it, and things like that. You can cluster it. It's very highly scalable. And message queues are more about, like, if you take money from one account, it better land in another account, or that operation should fail altogether. It shouldn't be where you take the money from one account and then maybe the other one happens at some point in the future, but nobody really knows. So message queues have these kind of guarantees about delivery mechanisms that Kafka really doesn't have as a design goal, if you will. So Kafka's.
I was just going to add, so message queuing is often referred to as reliable, with a capital R, and it's a reliable messaging. So it's guaranteed to go through, often idempotent, so you can actually rerun the same message multiple times and it will not trigger the same event again. Whereas Kafka is way more like a pipeline. And so it's like, we were talking about the Twitter fire hose, right? It's like, if you drop a couple messages on the floor, it's not that big a deal,
right?
Whereas like a message queue will never drop one on the floor. It's much more like a database. So it's in some ways similar to like storing something in, like a database versus, kind of storing things on a file on disk or something. It's kind of hard to compare, but Kafka is generally much more about speed of pipe, rather than guaranteeing every message gets through, whereas message queue is more about the safety and security and like reliability of the pipe or of the messages getting through.
Exactly.
So they're similar, but different use cases, similar concepts.
Yeah, that's why Kafka we can call out streaming platform for messaging and distributing storage and processing data continuously, rather than traditional the messaging technology.
Yeah, I would also say Kafka also does some can do transformation on the content as well. And whereas a message queue generally won't, for reliability reasons, so like or like auditability reasons. So that's not always true, but mostly true.
Yeah, and they also do things like flow control or back pressure, some of the concepts from the integration world that you'll find in message queues like native support for.
Yeah. Whereas, with Kafka, you just buy more hardware.
Yeah.
So, all right. So let's pause there. I'm not sure how many more questions we have, but we should try to hit the internet.
I think we're good on the questions. Let's go ahead and shout out to our build team.
Oh, right. Yeah. Sorry.
Yeah.
So, yeah, we wanted to bring it up, in our chit chat at the beginning of the show. We tend to, kind of talk about stuff that's going on. And as many of you are aware, it was Martin Luther King Jr. Day on Monday. And we wanted to kind of shout out to one of the practices that Red Hat does for a bunch of years now, and run by an organization called Build, which we figured out what is it.
Blacks United in Leadership and
Diversity. Yes.
Yes.
I'm of course blanking while under the gun. But one of the things that Red Hat does is like this day of service during MLK Day, and so where we basically organize a bunch of different activities that people can participate in, and if you participate in these, you can kind of take the day off from work without actually kind of treating it as a vacation day and work on this service stuff. And there was a hackathon in particular that took place that maybe we'll cover the results of in a couple weeks. I'm not sure. I know it was a 24-hour hackathon. I just don't know whether they were doing like when they did the judging, in a sense,
right?
Around basically some trying to model, if I recall correctly, safety stops in basically in various precincts, so that you can kind of categorize whether those are taking place in a good way. Yeah.
Yes.
So maybe we can cover that in a future show. But yeah, so we wanted to give a quick shout out. They do a great job. There are a bunch of good speakers that you could also kind of listen in on. They did a kids program as well.
Yeah.
So shout out to the Build team for putting that together.
Thank you very much for the Build team. Seriously.
And making it virtual.
This was the hardest year to do it, and they pulled it off with great success.
Right.
So huge shout outs and big props to y'all on the Build team. Thank you very much.
Yeah.
So
all
points.
right, and then points. Let's see if we can find the window. All right, so for our guests, one of the things we like to do in the Level Up Hour is we give out what we refer to as sweet internet points. And sweet internet points are, think back to Slashdot, old school, what they used to call karma. Same kind of idea is, if you participate in the show, we like to reward you for doing it. And so we give out these points, basically coming for the episodes, or submitting some issues, or submitting a PR against the episode repo, like the content for the show. And so here are the current standings. I'm just going to find the window. Sorry.
Wait for it.
Wait for it.
There we go.
There we go. Let me fix that.
There we go. All right.
And so, as I explained last episode, we have been messing with the numbers a little bit, except this should make most people happy. The numbers largely went up versus last week. They largely went down. But I think I'm done futzing with the numbers. And this is all in support of making these sweet internet points having a value beyond intrinsic.
Yes.
And
having a real value.
Yes. Well, hey, intrinsic value is real value.
True.
So I will throw this week's code into the chat. And hopefully I don't have any stupid errors, whatever. But Netherlands Hackham with 3,900 points, which is awesome.
That's awesome.
And Narendev with 3,400 points. I didn't see Netherlands Hackham today, but I did see Narendev. Noah Friction, 2,900. And then Joe Fuzz still holding strong at 2,200. And then I'm not sure how to say, is it detective? I don't know what det is supposed to be, but
Det Conan could be detonation. Who knows?
With 500 points, and then another newcomer, Tomas Mota with 400 points. And so thanks so much for participating. I think this is a hilarious part of the show. I really like doing it. I really like giving out the points.
It's one of my favorite things on the channel, to be honest with you.
So when we really appreciate y'all participating, James and Daniel, if you want to, all you have to do is go to the link there and you can get your own internet points. Det is short for detective. I thought so, but then I wasn't sure. I think it's a pop culture reference that, because I'm too much of a nerd, I don't get.
I'm gonna look it up now.
So yes, so thanks again for everybody for participating. We really appreciate it, and we would like to see more internet points in the future. And and I will I continue to try to convince other people on the channel to give out internet points as well, and maybe we'll get there someday. But yeah, that's what I got. Do we have any kind of closing questions or comments or thoughts or anything else that you'd want to kind of add?
I'm looking back through. NeurenDev, as always, wants us to make CRC speedier and more lightweight. I 100% feel your pain there.
You're not alone.
I get it. We're working on it. It's a work in progress. I don't see any other questions we haven't answered either via chat or talking. But yeah, Tillmore thought that could have stand for Detroit, and that would have made me happy, obviously. But it is apparently I don't want to get it wrong. Not anime. What's the other one called? Manga. Yeah. Apparently a character from that. So yeah, I looked it up real quick. I'm not in that genre, so I don't. I have no. Everybody wants a better CRC apparently. So
what's funny is I'm also not that into anime manga. I've seen some of it or whatever. But 2 of my children are crazy into it, and I don't know where they got
put them on. Man, you should just yelled over your shoulder. Hey, what is?
Yeah, exactly. Yeah, they probably would have. They probably do a better job hosting the show, to be honest.
It is anime. Okay, cool, awesome.
So yeah. All right. Well, thank you so much for coming. We really appreciate it. Hopefully, we'll have you back sometime soon. Did you have any kind of closing remarks or anything you wanted to kind of? Oh my God, I forgot to say.
No, I don't think so. I'm looking forward to my sweet internet points, my starter points.
Right.
So, I found that pretty fun. I was kind of worried it was going to be some kind of a quiz at the end.
That is not a terrible idea. We should. We did joke around about doing a Kahoot at one point and giving out extra points if you won in the Kahoot, but we have not executed on that craziness yet. So we'll see. Maybe.
Yeah. Okay. That's cool. Yeah. Thanks a lot for having us on. Very fun to kind of reminisce a bit about where it came from and where we're going with it. So hopefully we'll find some additional new features to add and more compelling tech to add to it to kind of showcase that stuff. Lots of interesting things happening to add to that.
Awesome. Well, cool. Thanks again. And
so Islam, there was a quick question at the end here about OpenShift cluster sizing and everything. Reach, I would say, potentially. It depends on the size and your HA needs of that production cluster. But it's always nice to have a backup cluster just in case you need to upgrade and an upgrade goes bad, right? So it really depends on your scenario. Work with your Red Hat account team to figure out what's best for you is what I would tell you, because there's no perfect answer for any, carte blanche, kind of organization.
It's the general. That's the general answer to that kind of question. Especially, how big is a cluster?
Right.
How small is a cluster? But I would say you're on the right track.
Yes.
It's you don't have to have 40.
No, you don't need 40 clusters. But yes, we appreciate everybody coming on. Tune in later in about an hour. We'll have the OpenShift Administrator office hours. So bring your questions and everything else. But we will be talking about OpenShift on top of Red Hat virtualization. So tune in and learn some Vert and some OpenShift all at the same time. It'll be awesome.
Right. Is it virtual learning?
No.
About Vert?
Technically, I guess, maybe.
Yes, you're welcome for the bad jokes. That will be it for the day.
All right.
Thank
you, Daniel. Thank you, James. And always thank you, Langdon. We will see y'all next time. Good luck out there.
Thanks, everybody.
Bye-bye.